this example, we have a product rule, quotient rule, and we have chain rule. We have an embedded function. So in the numerator, I have a product of e to the x times log x, and in the denominator I have my cos x embedded inside the squared. So differentiating this, y prime, I'm going to differentiate the numerator using product rule. So the first part of this is going to be e to the x times log x, or x plus 1, plus e to the x, and then differentiate log, we get 1 over x plus 1. Okay, so this represents the product rule of that quotient rule. So in the denominator then, we don't differentiate the denominator, so we end up with cos squared x. So the other part of the quotient rule then would be we don't differentiate the numerator, so we end up with e to the x. I'll just leave that in dark color since we're not differentiating that. So it's just going to be e to the x log x plus 1. Okay, and then we differentiate the denominator. And as we differentiate the denominator, we have to apply the chain rule. So I end up with 2 cosine x, and then times the derivative of cosine, which is negative sine x. Okay, so there's my chain rule embedded in the quotient rule. My denominator then, I square the denominator and I end up with cosine to the power of 4 of x. Okay, so this can be simplified. I don't really expect you to simplify this too much. There is a common cosine here that we should simplify out. It looks like, yeah, that's about, we can rearrange a few things in here, but for the most part you can leave your derivative expression like this. For the second derivative here, the d squared y over dx squared means that we are taking the second derivative, so we're going to have to apply the product rule and the chain rule here. So we're going to end up with e to the 2x minus 1 times 2 for the chain rule times cos x plus e to the 2x minus 1, so we don't differentiate that, and then we differentiate the cos to negative sine x. Okay, and there's our product rule for the first derivative. We do need to clean this up a little bit so that we can apply the second derivative. Okay, so that we're going to end up with 2e to the 2, let's factor that out. So e to the 2x minus 1 times 2 cos x minus sine x. Okay, so there's our first derivative. The second derivative then, we're going to have to apply the product rule again and the chain rule. So e to the 2x minus 1 times 2 cos x minus sine x plus e to the 2x minus 1 and then times 2 times negative sine x minus cosine x. Okay, it doesn't look like there's any identities involved in here. I'm just going to simplify that. So I'm going to factor out the e to the 2x minus 1 and simplify this a little bit. There are some like terms in here. So 4 cos, it's going to be 4 cos x minus cos x, so it's going to be 3 cosine x. And then we get negative 2 sine x, negative 2 sine x here, so we're going to get negative 4 sine x.